Now let's look at the periodic table. Today we are visiting the periodic table for the very first time. What is actually the periodic table? You see, we look at atoms and we are trying to understand elements. We did that too also. Um, there's a table that every chemist know about. This is what we use in most of our classifications. So all the atoms that we have, calcium, sodium, and everything that we mentioned so far, they are all put together in a particular table. It's a popular table in chemistry, and we call it the periodic table. So today we are going to do our very first visit to that to know the basic thing we need to know about the periodic table. So periodic table arranges these elements in a vertical order and then also in horizontal grouping. So there's horizontal grouping and then vertical groupings. All these things come together in a particular order. There's a actually particular, it's not done in any order, but there's a reason why they are put in every locations based on their reactions, chemical properties, and also their proton numbers, right? Today let's look at what is that. We are just going to have a fresh idea. We're just going to have a general idea about most of the components of the periodic table, and based on that, we'll be able to build on going forward with all the distance. Let's see. So the periodic table is looking this way. Yeah, this is the basic periodic table, the full periodic table. I know in high school, in junior high school, we learned the first 20 elements, right? Hydrogen, helium, up to calcium. In this in SHS, where you have to know up to zinc. But it's very good to know the full periodic table because sometimes the question comes from left and right. Just testing that you have a general idea about the periodic table, you know the periodic table. So let's all know the periodic table today. So the periodic table is this one. We have elements that are inside, right? We have elements that are inside. Let me see if I can get my. We have element hydrogen, helium, lithium, beryllium, and all that. So this is the full periodic table that we have. And then there is this ones also down here. These are the extra elements that we talk about. We have to focus on this one. We have these guys called lanthanide series and actinide series. Yes, they are also a very general way of this. So this is the full structure of the periodic table. Okay. Now let's try decomposing it into parts and understand what we came to learn here. First, you have to know this that elements of this sort, these elements are all the S block. So we are dividing them into blocks. The periodic table is in different blocks. Elements on this side are all the S block elements. So you remember on the ones that we have here, you see we are having helium here, right? Helium here. Helium is here, though, but then it belongs to the S block, right? We will tell you why it is belonging to the S block later on. And then right now, let's understand the structure that all these elements put together. Meaning, if you go back to the previous one, all these guys are all S block elements. That is also yeah. So these are the S block elements. The S block elements. All the elements on this side are all the P block elements. We call them the P block elements. And then the ones in the middle are called the D block element. So all the D blocks are here, from here to here, and D block. So we are first dividing the elements all in blocks. Then in a table, it's as if you are splitting the table, cutting the table into cakes, parts, and then each of them is a block, a block, a block. So the S block is this one, the P block is this red side, and then the yellow side here is the D block, in exception of these two. So that's why there's a star there, lanthanide and actinide series. So look, they are, if you put them together, even though they are under D block, when you get the full table, but then if you pull only these two out, you are going to have something called the F block. So they form the F block. Now, why are they called P block, S block, P block, S block, F block, and all that? We'll do that when we finally understand orbitals and all that, right? Yeah, right now let's get the structure that this is how they are. In terms of block, you have the element group as this. We need to know that this element belongs to this block, this element belongs to this block. Yes. Let's look at another thing. Yeah, the periodic table groups and periods. With the periodic table, I said it's grouped in such a way that they form a horizontal and vertical components, right? So it's just like a table. It's a table. So a table has a row and a column. So these things are called rows, rows, rows. So the row, this is a row. We can read this row. Then there is this row, also this long row going, this one row, this another row, right? Each row is called a period. A period. There are 7 periods in total over here. We have seven. 1, 2, 3, 4, 5, 6, 7. So we are referring to the rows that we have. The rows going down like this, right? Vertical. Yeah, that's horizontal. Horizontal arrangement of the element is called a period. So these are the periods. So when you look at the element horizontally and reading it horizontally to the end, that particular one line of it is called a period. So you can see that hydrogen and helium are in the same period. Lithium and beryllium, boron, carbon, they are all in the same period. Meaning that they are just in the same row. That's all. They're in the same row. That's all we mean. And also, these guys are in the same row, right? They all belong to the same period. Don't say row here, we say period for the periodic tables. In the same period. There are 7 periods in all, and we have all seen that. Now, the groups, the vertical component, if you look at it vertically, meaning if you look at it this way, this way, this way, right? We call them groups. So this is one group, this is another group, this is another group, another group, another group, another group. So the vertical view of it, the vertical selection of it, every vertical component, we call them groups, and all the horizontal we call them period, right? So you can see that hydrogen belongs to group. Here it is positioned as group one, and period one. If you come to lithium is this one, it is in group 1, period 2, meaning row 2, right? Sodium is in period 1. Sodium is in group 1, period 3, meaning it is in what? Row 3, right? In column 1. That's it. You can read this one, for example. You can read any of them. This one, helium, or let's say neon. Neon is in period. Which period is that? Period is referring to the row, right? It's period 2 and then row 18. All the rows, we call them what? Groups. All the rows are called groups, and all the columns, all the columns, mean the vertical component, are all called groups, and then the horizontal component, the rows, are called period, right? Now we know that there are 18 groups in total. Let's go a bit deeper into that, rows and columns. Yeah, we have the same periodic table, right? Now I want to talk about the groups, meaning the columns, right? The vertical component. I'm going to talk more about that. The groups. We say there are 18 groups, right? If you go to the previous one, you can see we have group 1, group 2, group 3, up to 18. Yes, there are about 18 elements, right? 18 groups. But then there's a further classification of such groups. We have IA, IIA, and IB, and all that, right? If you just take these blocks, the P block and the S block, you say that this is the S block and this is the P block, right? P block. Sometimes we are not interested in the D element. We are just interested in these two, in this P block and S block. We are not interested in the D block element. So for that reason, if you put the S and P block element, we can put them together and focus on a group. If you do that, we are just going to get 8 groups. If you take them, you are going to take only 8 groups. If you remove the D block and you want to count only the S and P block out and then put them together and talk, it's as if you are removing the D block from the component, right? Or that you are going to have one section of a group. They are going to be 8 because the D block, they are 10 in number. They have 10 groups. The D block have 10 groups. They add to the number to make it 18. That's the full group, right? If you want to talk about removing the D block and putting the other one together, right, you are just going to have 8. Because you are removing 10, which is the element. So if you do that, what do you have? So you see IA, guess we're group 1A, and then II is group 2A, meaning that A is telling you that you remove you are focusing on those ones that are above, like these blocks that they are taller than the D blocks are just here, starting from here down here. Right? These are the D blocks, but these are tall. So if you focus on the tall ones, the taller ones, what we are going to happen is that we call them A. The D block, which are lower, we call them B, group Bs, and then group As are the tall one, right? Okay, so if you focus on the tall ones, you're just going to have group 1A, group 2A, group 3A, group 4A, group 5A, group 6A, group 7A, group 8A, right? The A is telling you that you are removing the D block and you're focusing on the top block. You have the periodic table in your mind all the time. Now, but if you focus on the other one, right, the D block element, they are the B's, right? There's something funny about them. You see where they start? This is group 1B, group 2B, then they go back, group 3B, group 4B, group 5B, group 6B, group 7B, and then all of these, they call them all group 8. But if you see, they are 7, right? Is 8, 9, 10, something like that. So they are actually 10 in number, right? If you are talking about the B block, you can say that the element copper is here. Copper is in group 1B. You say copper is in group 1B. You can say scandium is in group 3B. So if you take B, the chemist, your fellow chemists will understand that, oh, you're looking at the B block only. If you're talking about group A's, you're talking about all the other ones, the other blocks without the D block, right? So sometimes they just say carbon from GHS. You know that carbon is in group 4. Carbon is in group 4. Boron is in group 3. Aluminum is in group 3. That's actually, they want you to, you are just basically talking about the A, the group A's, right? The group A. But if you want to talk about the full periodic table, right? Let me show you something here. This here, you see that aluminum is here, right? Aluminum is actually in group 13. It is in group 13, meaning that it's 1, 2, 3, right? If you consider the A's. But if you consider the full periodic table, there are 10 elements in between. 10 elements in between. You have to go 1, 2, at the 10, that will be 4 before you come to the 13. So the aluminum is in group 13, or aluminum is in group 3A. So if you say aluminum is in group 3, meaning that you are focusing on the A groups. So scientists use them interchangeably if they don't want to stress themselves. But then you have to know the full picture before deciding at what time to say what, right? You can say oxygen is in group 3, 4, 5, 6. Oxygen is in group 6. We can say that if you are telling me that oxygen is in group 6, I'm understanding that you mean it is in group 3, group 6A, then I will just understand. But the full table is actually in group 16. You have to add 10 to it. Something like that. So that's also, this is group 7A, group 7A, or group 7. If you say group 7, then we are referring to group 17. Group 17 of the periodic table. I hope you got that. Yeah, so the A and the B, that's just the difference between them. So you have to just worry. You just have to know this to be careful. So in case you are reading some stuff online, you don't get confused. In case you are reading some stuff in some books, you don't get confused. So today, I hope I've cleared that thing for you. Let's go and do further classification. Now we know the groups and this. Now let's focus on the elements themselves. Elements that are inside themselves. They also have their own classification. Whatever we've done so far is referring to the entire table, the blocks, the groups, the periods. And here, let's focus on the elements that are inside. Based on the position of the element, right? They also have their properties and characteristics. That's why they are classified in some way. With that, you can see all the metals. They are the basic element: metals, semi-metals, and non-metal. So metals, non-metals, and semi-metals. The semi-metals are boron. They are the green ones: boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. Right? But if you go to the metals, all these elements that are in the blue, including the lanthanide and actinides or the F block, they are all metals. So these are all metal elements, metallic elements. Non-metals, we see hydrogen here, and then these guys, hydrogen and all these guys are all non-metals, right? Yeah, these are how you have to know. So, and then you have to know the semi-metals as well. Semi-metals, they act both as they have both chemical and they have both metallic and non-metallic properties. That's why they are semi-metal. Semi means half, like half of it is having half of metal property and a half of non-metal properties, right? And what other classification do we need to know? We also have to know this, that we have special name for all the metals, right? There are plenty for all of them, but just know these basic ones. We are not going to worry about everything. You have to know the very basic one. The very basic ones include alkaline metals. Alkaline metals are the group 1 element. Group 1 element, they are all alkaline metals, right? So you know that hydrogen is a non-metal. We said that in the previous issue. But aside that, all these you call them alkaline metals. Now we have alkaline earth metals, which is group 2. So you see group 2A, so we are here. Group 2A, alkaline earth metals. They are here. They are the group 2 alkaline earth metal. They are all metals, all right, but they have classification. Group 1 ones are called alkaline metals, and except the hydrogen. Alkaline earth metals is the group 2 element. Then group 3 is supposed to have a name, right? They have names there, but they are mixed up over here. But all these ones in between, the D block or are called transition metals. And then the special one you have to know is the halogens. Halogens are all the group 7 A or the group 17 elements, right? Fluorine, carbon, in exception of acetylene. We say acetylene is a semi-metal, right? Remember that. So fluorine, chlorine, bromine, and iodine, they are the halogens. They are the halogens. They are very good. Will be very useful in most cases. You have to know the halogens, fluorine, chlorine, bromine, and iodine. You have to know them very, very well, right? They have to be your friends from now on. And then there's our last guys, another important group of elements called the noble gases. They are the stable elements. They are already stable. They are already stable on their own, right? They are very useful as well. So all these are the noble gases. Yes. So yes, this is the various parts you have to know about these periodic tables. This is a general overview of these. You know the groups, you know the periods. You now go online or go into the book and relate to all of this periodic table, because often this is what we're referring to mostly, right? So you should be able to know that, oh, if you see this element, oh, it's on the periodic table, it's over here. So it should be in the P block, it should be in the S block, it should be in the D block. So you should be able to tell that. As a chemist, you need to have that language. So I'll entreat you to all be visiting the periodic table from now on. I'm not saying you should go and learn it at once, you will grasp it. I'll watch this video again, and then you relate yourself to this periodic table thing. And then when it is time, when we are using them, you actually relate with us. See you in the next session.